Yes. Hey, folks. So I hope you all are doing well. So today we have one more amazing session with Vishwas on advanced Databricks. So I hope you will be enjoying the session and you will be learning a lot from the session. So yes, over to you, Vishwas. And we
Yeah,
have yeah. Okay. Yeah, you can
thank
start.
you so much, Wilsey. Thank you so much. In industry as well, in as well as the people who are working with Databricks for a very long time, there's an abrupt understanding about like what is the potential of a Databricks, what can it bring on the table, and everything. So basically, Databricks is an Spark compute workload. Like you need not have to do any sort of an installation. You need not have to do a specific job in terms of an ETL to be built or anything. So let me just share my screen. We'll go to the whiteboard and I have some little bit of notes, probably a pager plus some more topic that I have in my brain. I'll just do that and we'll go ahead with a lot of things. So that's perfect. I think we'll go ahead with this. So what started off as an humble attempt in order to give you some sort of
Vishwas,
an
your screen
resources.
is not visible if you are
I
presenting.
shared the screen, but like I think he didn't put it on the screen. I think you guys can. I've shared my screen actually.
I'm not able to see.
Yep, I think he has to click on it, add to stream. So yeah, add to stream the screen one. Yeah, I too am not able to see the screen.
Yeah.
So I'm able to see my screen here. Like I have shared it, but like it's not being added to the stream.
On the stage, yeah.
Yeah, I'm in the backstage. Varun,
It's
like you
just
can join in and you can just add it to the stream. That's it. Yep, it now arrived. So
it's
it's very
visible now.
simple. Yeah, yeah. It was just a new one. So what started as a Google file system paper. This was the file system paper which came out in 2003. Why I'm giving you the time frame is like big data is not a myth or else it's not a new trend. Big data was already there. Like I can say you one of the resources here. It's a very simple one. So you guys can go to archive machine or else anything which is very close to archive machine, wayback machine. Sorry for that. So it's a wayback machine. Okay, so if you go here and check out what is this Google thing going on and things like that. So let's say HTTPS Google, right? Or let's do this. So this was the URL which they had. So let's go ahead and see what was the way in which it was actually being there. So right now, I'm talking in terms of February 17. You have 37 snapshots. Like just imagine the amount of production issues and all the changes which has happened from the Google and everything. So this is 27, 28 snapshots. So if you can see that, that's also there. But look back at it. There was a form where the big data was booming up and everything, right? So you guys can go back and see what happened on this day. Like you can see what was the snapshot that was given here. So you can see that, right? The way in which the data was being changed, like from the Google, it was there like that and it's still available to you. So let's just see what is this actually all about. So this was how the Google looked back then. I think LE just came up. So this is the old logo. If you don't remember this shade of graphics, sorry for that. You are not that old as well. So don't worry about that. So this was how it was looking. So now there was an always an understanding, like in this paper, it was always like, okay, we have a data, we just batch it up, we just play around the algorithms, and also there was a need for us to realize that, hey, we are collecting 1 TB of data per second or so. Let's say what if we scale up to 1000 TBs per second. Like this is what we are talking in terms of, right? And probably a 4K or an 8K image is more than a GB today. Like it's how it is. Then later on Google came out with its own project called as MapReduce. So it's called as a Google MapReduce. So this was in a timestamp of 2004. I think amazing scientists have really worked hard on this, and this had a feature in which it gave the scalability of it in such a way that, let's say, from 1 TB to 100 TB, there was a seamless scaling which was happening. This was what this paper was all about. Like, how can we seamlessly scale it up? And what if our cloud environment is not built to such kind of a thing? So it also talked about redundancy, and it also talked about layers of abstraction. So that layers of abstraction, what I'm talking here is probably in terms of the way you are going to have a data inside your data center. In terms of, like, if you have more amount of images, if it has a frequent access, then that will be basically used in terms of caching and all these things. Like that was where the concept of caching and everything came in, right? Redis is the biggest player in that, of course, but like every component really requires a sort of a cache. Even MapReduce today also uses a lot of cache today. So this was what we are talking about. Then you're like, okay, fine, we have an huge amount of data set. So now they started realizing that process, right? It was like, let's just input the data, split it. Like, I'll explain it in a very detailed fashion, don't worry about that. And later on, let's just try mapping it. Then whatever we want to do. So we knew that we can split the data into hundreds of it, but how can we map it? That requires a lot of intelligence. Intelligence was actually never an AI or anything. It was just a simple if else statement only. But even for some of an advanced analytics methods and technologies, they still used it. Then later on, there was something called as a shuffle. So data wrangling and all, it's just a shuffling of the data. Then what we did was, okay, if we have this amount of abstraction, if we have this amount of process, then we are actually overloading ourselves with a lot of memory, and a lot of data is to be taken care. So let's do one thing, let's just reduce it. So this is how your process looked like back then. It was just an input which was supposed to be split, which was supposed to be mapped, then shuffled, then reduced. So let me just give you a quick insights about it. This can be in the form factor of an image. This can be in the form factor of an JSON. Yes, JSON existed. 2001 JSON existed. And I think I can show you one of my LinkedIn posts which talks a lot of Databricks. I think you guys can just see that. I think that will be like awesome. So yes, let's go ahead and see what was this Databricks. So you guys can share, you guys can follow me, follow my hashtag Azure Sketches. So I do a lot of Azure Sketches. I think this was one of the Synapse thing that I ever did, and it's a pretty good understanding that you can have about all the synapses, ingest, everything. So we can talk a lot about Lambda and Kappa architecture in the later part as well. So don't worry about that. So yes, this was the one. So that's perfect. This is also perfect, and all other things are data bricks and other things. So yeah, it's pretty much this that I wanted to show. This and this. Ah yeah, CDM. Where is my CDM? I forgot the CDM thing, man. I don't know where it is, but like if I find it, I'll share it in the comment section down here. Don't worry about that. So very simple. Let's just open the image in the new tab. Let's just open the image in the new tab so that we can see a broader spectrum of those images that we are just talking about. So, all right, it's very bad. I can't reopen the tabs here. So it's a very simple thing. You guys can go check out all the things that I've been giving here. I think will be sorted for you folks. Yep, I think this size is good. Yep, this is good. This is also good. This is very bad, but you can understand, right? There is different sort of delta cells and everything. So wait. So this is an CDM canonical data model. That's fine, but I need a lot of other things as well. So let it be. We'll go ahead and we'll just do it. So this is what I'm talking about, the canonical data model, right? You can get it in the form of a canonical, like it can be from any sources. It can be from Dynamic 365, Power Apps, Microsoft Offices, ISV partners, internet service vendors and providers, everything. IoT Hub can give you a lot of things. So it can be of any form factor. It can be of CSV or else any of the CDMs. You can take CDMs as well. So this is how you get the data in. It's a raw thing. It's just ones and zeros, and nobody cares about it until and unless it runs through all these processes. Like, until and unless it runs through all these processes, nobody cares about it. So splitting was supposed to be done based on the quality of the data, quality as well as the quantity of the data, because it's like how many images have I collected, how many JSON scripts have been just being rendered out from all these different data sources, and also the variance of all these, like how often do we get it. Like I might be getting image data set for a very long time, JSON sometimes, but like CSV for a very long time. CDMs can always be happening from different services in the Azure and everything. But this is what we are talking about. So we are talking in terms of the quality of the data, the quantity of the data, and the variance which we are seeing in terms of the data collection. So this is where we are splitting it into different parts. And over a course of time, all these processors just led to one thing, like let's just map all of this together. Let's just build it in a form of a data frame. This is what you will be doing in your entire Databricks infrastructure. Then let's just do one more thing. Let's just not just keep it in the form of a data frame. Let's just make it compute friendly. So your aim today, when you split, map, shuffle, or do anything, you make it compute friendly. How? I'll say you how. It's a very simple concept. There is something called as horizontal and vertical scaling. So all these vertical scaling, horizontal scaling, what you are seeing right now is basically a step to increase the compute power as well as increase the process velocity. So velocity is always the key factor here, because it's like, it's like you have the train, test, validation, build, deploy, and everything. Even after deployment, you are supposed to collect the data. And now again back, train, test, deploy, build, deploy, and validate. A lot of things will be there, right? So all these processes requires an high speed process serves, and also these are something which is more compute intensive. That is where Spark also shines. Spark really just brings that magic onto the board. It's like, okay, I just have this kind of a data set, so now just increase the way in which you are producing from it. And so we just made it compute friendly, and now you have a reason now to say that, hey, let's just randomize it completely. What happens if we don't randomize? What happens if we randomize? Let's say yes is if we randomize, if we don't. So now when you randomize, you are pretty sure that data is not in a flow. In a flow का मतलब it should not be some sort of a repetitive thing. It differs on when you are considering different types of a data set, like time series data sets are different, whereas you are considering some data sets for the regression and classification, that's a different story, right? So now data is not in a flow, and data is well learned. concerns about the data, don't think about the order. Let's say it's an order of me growing fat. Okay, so Vishwas last year had lost 5 kgs and this year gained 5 kgs, and the present year he tried losing 2 and gained 1. Like, this is not a pattern to me, right? This is something which is randomized and things like that. So now let me just say, uh, it's something like a well-known thing. It's like a car engine. Let's say car engine, if you go at a speed of 5 kilometers per hour, within an hour you complete 5 kilometers. But let's say there is a breakdown, or else there is a malfunctioning and everything. So now you go at 4 kilometers per hour, and just by knowing the pattern that you just went an hour and you covered 5 kilometers, it will obviously say you always will cover 5 kilometers. That's dumbness. But later on, when this just pattern is learned by saying that, hey, this kilometer per hour is equal to the time which is being spent, so let's keep it 4. So this will be the insight that will be learned, right? So this is what I'm talking in terms of an advanced level analytics. It's like it should know where to learn the pattern from, it should know where to analyze which module you have to be moving towards. So it's that, if you don't if you don't randomize the data, it's very simple. There will be a chances of your data overfitting. Ka matlab, it just gives out 100% efficiency at every given point of time, but it has not learned anything. That's the overfitting. Don't worry about it. It's a very pretty big concept that we just going. And there is a chance that you have a data drift. Data drift is nothing but a pattern of data which is not seen again, which is like completely scrambled. So pattern is not present at all. So if it doesn't see that pattern, it will give as many insights as it can, and it's like done. I don't have that sort of an insight. Sorry for that. I can't work on it. So lastly, we'll come to the reduce part. Reduce part is basically a simple functionality in which you're collecting the required data. You're collecting the necessity of the data, like necessary data, and you are actually making sure that you have a clean data as well as a shorter version of the data. It's like the compressed data as well. So compressed data. So over a course of time, this is what you're thinking. So necessary data is basically a clean data. You can think that way as well. So this is what we are thinking about. So right now, when you think about this entire infrastructure which you have in front of your hand, you can just go ahead and see what was the actual beginning of the Spark. Spark as a project was donated by Databricks, which was started in 2012. Its name is Metal. Zaharia, one of the professors from MIT, who saw a need for uh, getting Hadoop infrastructure, which started in 2006, to make it more developer friendly. So now they made it more developer friendly. So now this was donated to Apache at 2013. And right now it's in a form factor of Spark. So right now, when you are thinking of all these kind of a timestamps, you all should be knowing that, hey, there are a group of academicians. What can they do, right? But academia had a very big twist. They were really working on genomics. They were really working on computer vision. they were really working on self-driving car, SDC, self-driving cars. So right now, when you see genomics is gigantic amount of data. Computer vision is too much of an image data set. Self-driving car is like every matrices. I can give you one of the slides that I actually did recently. I can show you that as well. I think it's Google's slides here. Google Slides is here, and I have some notebooks as well, so don't worry about that. Where is that notebook? It's Vishwas Narayan. So I have two examples. It's basically in terms of the data frames and everything. I think this ran properly. That's not a problem. File store. All right. Compute's instance got detached. Wait. Nay, 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 nay. I just want you to run again. So it was AutoML. So I'm going to start you again. I'm going to start this one again, as well as this one again, because there is a notebook which is running and everything, right? So I think I have written a lot of scheduling there. I think that should have actually given me a lot of things. So this is how you write, right? I think Databricks run ML flow example has started. ML flow example error. Okay, that's perfect. See, like I'm saying you right, every little seconds, like if you really want it to happen, it will say that. So AZ305, it's coming from text scalable. Oh, right. Nothing much, so don't worry about that. So I think there is an workspace. I can go there and I can check what is happening. So that's fine. You can check your errors, which is also there. Check the error in this run. So perfect. I can go there and check out. So this is what I'm saying. I had scheduled this. Now, I had scheduled this notebook, and it really gave out that entire entity, and it was pretty awesome, right? Job IDs, everything is coming. It's failed. Basically, you're DevOpsifying the Databricks pipeline. So that's perfect. So where is this? All right. Command took. That's all right, but like, why did it fail? That's the key. Yeah? It's not a problem. We can go ahead and we can see it. So simple. It's basically you saw the timestamp in which it was being developed, and now there was a contribution from STC and everybody, right? Oh, sorry, I should give you the slides, right? The slides is here, so that's perfect. Sign in. Self driving car. So yeah, I got some of the slides from MIT as well. Where is this? Driverless cars. Yes, you guys can go check out this slide, as well as another slide which was black. Yes. So right now you guys can see all the slides that I'm given here is here for you. So you guys can go check out those slides. I'll say you why, because a lot of times we might think that programming an AI is a big deal. No, program a missile system, you will understand what is a sampling space, this, that, and everything. So don't worry about that. Everything will be sorted for sure. And I think you can follow my hashtag Azure sketches as well. So please do follow that so that we can collectively learn together. And of course, a lot of podcasts from my side from different professionals. You guys can go check it out. Driverless cars are pretty awesome, my friend. So let's see the entire Spark and every infrastructure that we'll be talking. So now it became in a form of an Apache Spark. Now we have Spark as a massive support for ML. It also has massive support for a graph kind of a data set, which also offers a support for streaming. Basically, streaming comes into picture when you have Lambda and Kappa architecture into the picture. So it's all still the SQL, Postgres SQL, all these things. And streaming is the most important step in your Databricks. So let me just give you a big thumbs up about it. So what's a streaming impact on your Lambda and a Kappa architecture? So let's say this is a Lambda architecture. So So in your Lambda architecture, there is always a layer of compute, there is always a layer of processing, there's always a layer of data ingestion, but there's always a process which is always dedicated for streaming. Basically, when you're streaming a huge set of data set, you're saying to yourself, can I make it real time? Yes, Lambda architecture is the key for it. But the Kappa architecture is very unique. A kappa architecture basically eradicates the concept of streaming. So there is no streaming, which just has compute, which just has processing. That's it. So if you want to basically build it, the only step that you can do apart from streaming, there is no streaming concept, right? So apart from all these, what you can do is bucketing, and there is something called as batching. So this is how it is. There is a requirement of an hour saying that, hey, this entire infrastructure is okay, which has all these kinds of an insights, which has all these kinds of an capabilities that is just being bought on the table. But right now, how can I utilize it in form of an whiteboard or something? So this is how you do it. So Lambda and the Kappa architecture, there is just an understanding that is required for you. So let's just go ahead and see some of the notebooks that I've written right now. So let's just go ahead. So MLOps is going to be a little challenging. So don't worry about that. We'll go step by step. So as told, it all starts with an amount of entity which is always being taken care, right? How much of a data can I process in the real time? So I think I need to get my zoom in. Perfect. So Spark and SQL is now being connected, and you're now saying, hey, data frames in the form of SQL queries. This is what you're saying here. Of course, you are using Python, but now you want to make sure that this Spark has an SQL queries taken care. And right now, what you're now just doing is dividing it in the form of an session, right? You are collecting the same old data frame, but you're dividing it in the form of a session. So this session is going to be like an entire workflow. Like this is going to take care about the Spark. Right now, this has now really taken that compute, install the Spark on it. Of course, this is a Databricks instance, install the Spark on it. Everything is being sorted. So to those folks who are very new for all these kind of a things, very simple. Just go to the portal.azure.com. We'll start from the basics. Yes.
And I
Yeah,
think
yeah,
like you
you.
have also done a session before.
Yeah, yeah,
Okay.
I have done a
I
session.
think you have done. Yeah. So like for beginners, if anyone is beginner in Databricks, so they can check that session out also on
Yeah, like it's
Databricks.
very simple. You can just go create a new resource group. Say that, hey, new
Yeah.
1, 2, 3, 4. This is the thing. And then you need an instance name. So name it Vishwas Narayan. I think I didn't name that. So it's still saying a green tick here. So that's perfect. And now go and review and create. There is no tax required and everything. Of course, there is a lot of networking and all these concepts. We can go ahead and we can do that as well. So don't worry about that. So I've created it, validation done. So we're just going and creating it. So it will be created. So don't worry about that. So in a very big nutshell that we can just say about like is, I think in a very big picture, brought into a nutshell is very simple. It's you just go here. click on that resource group. As soon as that entire thing is being built, you have a resource group. That's perfect. Now just go back. It's just the Spark and everything which is being installed. But right now, if you just click on the resource group, there is there is already a new resource group which is being created. This is for your Databricks resource group, Vishwas. That means I had named my Databricks instance Vishwas, and now it's Vishwas right now. So back end, you can see that there is pretty much a good number of disks which has been created, VMs which have been taken care here, and everything. All these VMs that I'm talking here goes back to the compute instances that I'm running right now. So all the VMs that I'm running right now, all the nodes, all the pools that I'm running right now, it's there for you. So Databricks made it very simple for me. There is already a network interface card, there's already a disk which is attached, and of course there is a VM which is already being created. And of course, apart from that, there are some more concepts called as network security groups, the folders, public IPs, everything which is being created is being taken care of here. So worker SG and a VNet which is being still created. So this is what I'm talking about, an end-to-end system designed for your big data. So if somebody says VM is so absolute, sorry, bro, you have not seen it. Basically, a VM just means that it's just a part of an data center. This is an entire data center that you have. A VM is something like you're just controlling a part of a data center. And this big picture that we can now say is a virtual machine. It's a VM that we just created right now. So big things coming up. So let's just get up. So I think already it was created. So it already got sorted. So 47, 48. I can delete this and I can show you the scheduling. Like it happens right now. So I think I can delete last two cells. It's of no use to me, so I can delete that. That's not a problem. So very simple. I can schedule all these workflows. I can say that, hey, you know what? You can really ingest a good amount of data, batch it up, store it in the form of a data set, format it in the data store, and now you can schedule it whenever you want to run it. It will just keep running. So it's a very simple thing. Go to the data here. The data here will be the data store. It will do all the magic to you. Just go ahead, just create a new table, upload a new file. There's also called as data break file system, so you guys can go check it out as well. And there are other sources. There is Azure Blob Storage, JDBC, Kafka, Redis, Elasticsearch. You name it, you will get it. And the partner integration is always there. So stream sets, of course, is an advanced topic. So it's a pretty advanced topic. So it's basically you're taking the delta frames, putting it on a form of a stream, using the stream sets to get the data. It's a perfect example for all of this. So you guys can go create it from the blob storage. When you are creating it from the blob storage, you know that, right? This is what you really want from your blob storage, and it's already ready for you. It's just an basically a one-click solution to access all your uh, data from the blob storage, and the file location, if you know it, perfect. You can just go ahead and just grab it. So everything is sorted for you in your Databricks. It's a quick walkthrough that I'm giving so that you guys will understand what is this Databricks all about. So let's just go ahead. I think enough of the discussion. Let's just run through the code. So right now, I wanted to create a column which will be in the form of a data. And let's say I'm running a company which is using these many languages, and how many users do I know have it. So what I did was I just created a simple interface saying that, hey, there's a good amount of columns that I have right now. So, okay. So I have a good amount of columns which says that I have SQL programmers, Python programmers, Scala programmers, R programmers. Of course, running a big data company and things like that. And there are 20,000 users who know how to use an SQL. Of course, 1 lakh users know Python, 3,000 know Scala. That's also perfect. 3,000 know R. This is not a niche data set that we are talking here. It's like a known one, known fact. Most of them know Python, most of them know SQL, some know Scala, some know R. That's perfect. So what we can do is we can still run this entire code and we can just go ahead and start working towards it. So we can go ahead, run this. I think perfect. So you guys can see that, right? So now it's 2/8/22. And now during the 12 o'clock 41 p.m. that we started, now it's already being created. So now I was like, okay, fine, this is actually some sort of an example that I'm just giving, just an app name. Let's see whether this exists or not. Spark by example, of course, you guys can go check it out as well. Like everything from end to end about the Spark is being given here. So you guys can go check that out. So that's what we are talking here. And later on, so there is an RDD which is being created. What's an RDD? It's a very simple explanation. Don't worry about that. I'll first go through the Google and we'll just make sure that RDD in Spark. It's a very simple resilient distributed data sets. What is it all about? Basically, you are building a fundamental infrastructure to store your data. And now, if there is an anomaly created, you need to understand it and you need to reduce it. How? So, an RDD, resilient data set, which is a data store right now, which is and supports for a Spark. And now these two are doing all different sort of analytics, all different sort of jumble and mumble and everything. And they are now coming to a conclusion that saying that, hey, we have a data set. And now this data set has an instance, which is now being computed. Afterwards, what we have to do is keep the cleanest, keep the cleanest and delete the rest. So delete the rest is basically something like you are saying that, hey, I need to have a full on from clean data. I need to have the versions of it. So if I want to roll back, if my training goes bad, I need to roll back, right? So this is what you're saying. Hey, just go ahead and start working towards it. And there you have it. So this is where the function of an RDD comes into the picture. An RDD is always about like, can I get the cleanest form of the data set? Yes, of course. So let's just run it. So RDD, well learned. And also, if I do the Spark, check out what happens. It opens a new tab called as Spark UI. Just go ahead and click on it. You get an entire information about your Spark cluster that you just created. Like how much was the total uptime, like what was happening, fair amount of scheduling, so event timeline. So you can see that, right? So there was an execution driver and the 21 and there's 29, there's an execution which is happening right now. That's perfect. So how many succeeded, how many got removed, how many are failed, everything will be in your entire space, right? This is what you do over a course of time. Whatever you do right now is basically this. So and also you can analyze different matrices, executor, how many JDBC ODBC servers are there. JDBC servers, an advanced topic, so we'll go ahead step by step. Don't worry about that. If you wanted, so Databricks by wishwas.web.app. You guys can go to this notebooks and you guys can check out all the notebooks that I've written. It will give you all the insight. I think this notebook will be updated very soon. Don't worry about that. So let's see what is an RDD doing here. So RDD is now there is an parallel collection RDD and then read RDD format input streams, and it realized that I am doing Python. So in this time frame, I'm just taking a Python RDD, which has a Scala wrapper, and it's now running. That's perfect. So two data frames is what I'm considering right now, and you can see that it will be converted into a form of a data frame. So this is what the function is all about. So two data frame function is already being converted, and it still uses the same old RDD and all these kind of Python abstraction and the Scala wrappers and everything. So and this will be sorted for you. So as soon as you click on the view, you can see what's happening with this entire data set, like how many jobs got run and everything. So if you later press on the Spark UI here, you will get all these details. So you can see what are the number of stages which happened. So like you can see, right, stage ID 0, which happened at one given point of time, like it's 6:35, 13 minutes, I don't know, like this is different stages which happened. I think it talked about the two jobs which ran out. Perfect. Storage, how much is the storage in the Spark instance which is running? So it's 0 bytes, that's perfect. That means that this is running on a local system and it's not causing a huge effect on your future ETL pipelines that you are going to build using the Spark. And executors are here, how many executors have been used. So it will take time. So you can see that, right, amount of memory used, the time taken to do all these kind of an operations and everything. So it's now being sorted. Is there an SQL? Of course there is no sort of an SQL which was done, but it internally created one. So how many queries were being taken care? So if you see the details of it, it will say expand all the views, show me the details of it. And it says that there was an experiment run and this was the logic for it. So screen as page, you can send it to your customers as well, so don't worry about that. So this is the best part about Spark. It's like everything is in a form of an dashboard, and you can just go ahead and start running it. So it's been 18 minutes since I've been running that compute instance, and it now gave me that information. So let's just run this and see what is this code all about. This code is just saying that preload classes were always there. There is always a logging function which is already being created. And right now, let's see. From RDD1, it's just created a two string. It's a very simple thing, right? It's a language and a user count. All these things comes in a form of a string. So that's what it gave. And it's still the same old thing. Two data frames are just created. If you can see all the Spark jobs which were being running. So I think 01 was also being shown now. So this is a job 2. If I say job 3, it should give me all the information about it. So it's running perfectly. If you can just go back and just click on this restart thing and everything, if I refresh, if I run it once again, it should show me that, or else it will not show me that. That's not a problem. So all these executions still remains the same, but see the magic of this one thing. you know I just wanted to get rid of all those JSON and YAML and all these kind of a nonsense that we get when we are configuring a lot of database schema and everything, right? So now you just made your life much more easier just by putting in Spark types, structure fields, and right now we just created this kind of an instance. And this instance really worked well for us. So right now you just created a stream schema and you just did the job. And see the magic of it, it already created a table for me. It's very difficult when you are doing such kind of a thing. Like you can append as many inputs as you can, but putting it in a form of an very nice looking table and just throwing it out for the training in the future, that takes a lot of time. And similar thing, I just did all the paraquet jobs and everything. You guys can see that there is an n number of matrices which were being considered and it's being sorted. So if you can see that, what is a paraquet? Paraquet is very simple. So let's just go with the Google paraquet in Databricks. HDFS is also there, but I would say just go with all these definitions. So paraquet is just an columnar representation of your objects, and all your JSONs and CSVs and everything will be stored in a form of a paraquet. But if you want an advanced introduction, just go ahead and go with a Delta Lake in Databricks. So now it's being perfect. It has a default paraquet. It has all the things sorted for you. So you need not have to worry about it. So I think there is a lot of compute instances running. That's perfect. And as usual, it's now being taken care. and it now knows what should be the, like, I don't know, like, I just created some data set, that's it, oh god, have made some blunder here, but you can see that, right? The way it was being created, everything is being told to you, and all the things, everything about an information comes in. So this is what you require when you have an ETL pipeline, which is extract, transform, load, in your big data environment. Like something like you receive data in terms of petaflops of processing required. Let's say ETL, it's extract, transform, and there's something called as a load. What you do is basically extract the data from different rows, resources and sources, from different sources. Now you're like, let me just transform this and see what is going to happen if I just do a lot of transformation. Like it can be in the form of an algorithm, just churning out the data and saying that, hey, this is what we are going to work, or else it can be in a form of a data format itself. So there are different data formats, there are different methodologies that you can think about. So you knew all these kind of a functionality, and now you know how to load the data. Like that becomes a pretty big challenge. It's still the same old X-test, X-train, but can you do it seamlessly? It's impossible. So what you do is you want a loading mechanism which says that, hey, there might be some redundancy, there might be some logic mistakes which can be going, but how can I build an infrastructure which is much more sturdy towards it? So a load mechanism will always be there. So it's a mechanism, by the way, which gives you all these kinds of an input, and everything will be sorted for you. And all these things, what I'm talking in terms of the rows, columns and everything, is now taken care, and all the things that you're just considering towards building all these data frames and everything is being sorted for you. So let's just run this. It's still the same old way of saying rows and columns, but in a shiny fashion, that's it. So yes, you can see that, right? As soon as I run it, there is a different timestamp which was being taken care. So it knows that there is a date. Perfect. Now there's a time which is being added, which is like 2000 second, this and that. So now it knows it's a timestamp, a double, a big integer. So yes, it knows what's the big deal with dealing with such kind of a data, and it's now being sorted. And over a course of time, if you want to repartition it, just see the magic of it. You get an access to an entire compute, saying that, hey, now we know that this kind of a data is there, but now it's not optimized, right? So what we do is we'll optimize it. So the big int here became the long data type, string became the string, date became the date, timestamp became timestamp. That's perfect. This is what you call the data transformation. And now you do the same old a, you get the same old a which says that, hey, a was just an integer which just said it, but like when I just converted into this sort of an form factor, it now just became different. And let's just collect the data set and see what's the magic of it. So you guys can see that there is a job 4 which ran and says that 8 successful runs, and a pool name is basically like you're basically saying that, hey, this is a compute instance, can you really give me an access to it? So since it's a Spark pooling, everything is being taken care of here. So you guys can go jump to any of the pages and everything, you'll be getting all the information. So now let's just see what was the data set which was being done. So I think probably this was ran and perfect. And lately, similar processes, similar way of putting in the data frames in uh, different data frames and everything. So pandas, I did one, I did on Spark. Now I'm just creating a Spark with respect to the context. And it now came in. And if you can see that, what really happened It's now just giving out the same old data set. It's now giving out the same old A, B, C, D, and all these transformations, and it's now just throwing out the data sets. And that's perfect, right? Let's see what's the magic of it. And it's now being sorted. This is also now being sorted. So all of it, what I'm talking here is an end-to-end data transformation with a real-time processing. It's like, of course, you might have batch the data. If I schedule it, probably this is going to change the way in which we're working. So in a day or our minutes, every minute, if I want to keep running it, it will just keep running. So job ID was successfully run. I have a compute instance, and every time there's a every minute, this will just keep running. So recent activities and everything is being given here, so you guys can go check it out as well. So simple thing, very simple thing. You don't have to worry about it. Just go through the data, go through this notebook. I'll be downloading it. I think I can export it in a form of an HTML. I think so. Yep, you guys can go check it out. This will be updated in this blog here in the notebook section. So don't worry about that. So this notebook will be there for you folks. And you guys can see that, right? The amount of data that you were churning out was huge, but you now made it automated. Like you just automated the entire build process, and everything is sorted for you, right? This is what I'm talking about, an end-to-end computation that is being leveraged today. And yes, I think there is a huge amount of jobs which were being done. I think we can view what happened in this job. UI cluster, it may take few minutes because it was a previous run. Probably this will give a lot of information about me, saying that hey, 222, I think 4 hours before I was just running this demo, and over a course of time it now got sorted. And there it is, folks. You just got to know how to work with Spark with a lot of diligence, like in terms of taking in the data, churning out, transforming it in the real time. That's the magic that I'm talking. So you can just go out and just get all the results out, and you can show it to your friends, and that's also there. And side by side, you can have all the results and all the commands, what really ran and what didn't run. Everything can be seen here, so that can also be done. So basically what you are just thinking about is, like, can I make this a dashboard? Yes, you guys can make this a dashboard, and you guys can see that, right? How many of the dashboards that we can do. So Vishwas, present the dashboard. Yes, you just presented it. Can I update it? So why it's asking me for an update is every minute I've made it to run, right? So you guys can see in my mail that it's now running. So you guys can see that, right? There was a data run, view this run. Everything about this entire data set that I was talking about is now being considered. So this is the scroll to error. Module not found. ML flow. Why? I don't think so. I should get an error here. That's perfect. That's not a thing. Scroll to error. ML flow is not considered. Why? All right. It's still saying me update, update, update. I'm like, let's go ahead. Let's move to the magic of it. Let's just see what was the scheduled run. I think the last run was there and it's still now pending. We can run it now. So running the job for Vishwas, that's also there. So pending ka matlab, you can see what and all has been run, what and all run was skipped. That's okay because I can do that as well. So day at 12:19, that's also there. Every hour at 19, that's also there. Like every hour at 19, it will start running. So this is what it is. It's just being successfully run, and every time you can just churn out some new insights. So yeah, you have an end-to-end interface right now. You have an end-to-end build which happened right in front of you, and you also have the results of it. Like saying that hey, there was an error which happened. Why? This is the reason for it. That's all from the computation perspective side. So you guys can go check out the scale set as well. Very simple. Compute instances are coming up with huge amount of scale sets as well. So let's say a scale set example. So it's a standard one. It's still going to be a Spark instance. I can run it in any type. If I type in the data blocks and everything, it will just be affected in most of it. But if the requirement comes in such a way that, hey, minimum worker nodes has to be 2 and a maximum has to be 8, I can start creating as many clusters as I can. And this is now being created, right? In the back end, when you go back to the network resource RG and everything, if you just click on all these things, you will see that there is even more amount of resources which will be created. So let's see that. It will take some time. That's not a problem. And a very very specific thing that I wanted to say is that you can install all the libraries that you want. It's a very simple thing. Go to the compute instance. Very simple. It has all the thing configured for you, so don't worry about that. Just go click on that compute instance that you created, which is running, and click on something called as libraries. And when you click on something called as libraries, you can install a new one. You can think of any packages that you're just going at. So I want to install ML Flow Beta. Like there is no ML Flow Beta or anything which is there, but like let's see whether it exists or not. So I choose a PyPy package and it's now started running. When it's there, the package is installed will be showing installed. If it's not there, it will show failed. It doesn't have an installation. Install the cluster. If I make this, it will get installed in all the clusters. So I don't want to do that. It's an added complexity. That's it. So let's see why the MLflow notebook didn't work. MLflow notebook should have had worked because it works for me, right? It should work for the other folks as well. So it's a Vishwas one. So perfect. So if I do all the pip list kind of a thing, it will show me all the dependencies that I installed and everything. So it's a similar thing. It's a similar thing. When you have a compute instance, you are just doing it, right? So that's the simple analogy that you're giving here. I think this will be created in some point of time, so don't worry about that. So as soon as I click on it, one, two, three, four, five, six, seven, and eight, nine, 10, 11, 12 VMs have been created. Man, this is crazy. This is crazy. 12 VMs have been created, folks. You can just imagine what and all did we do. Guys, if you have any queries, yeah, feel free to ask. Reach me out on LinkedIn. I do amazing sketches, by the way. You guys can follow me. Don't worry about that. And wait, ML flow is still required, so don't worry about that. We'll just go ahead slow, step by step. Don't worry about that. Just go step by step. If we just make a hurry of it, please tell me when to end the stream. I will see you. Don't worry about that. I think scale set has been created. I think if I click on it again, I think probably there should be a good amount of VM which should have been created. I think North Central US. When was this created? Let's see. When was this VM created? Ready agent pool. Public IPs here. God, this is awesome. By the way, this just got created, man. Perfect, perfect. So CLIPS, shit. This is awesome. This is awesome. We just created a humongous amount of skill sets. So that's perfect. We can go ahead with it. So very quick intro to your ML flow. ML flow workflows are very simple to be installed and kept running. So let's just go to the ML flow. I think I can remove tabs to the right. So Your matplotlib, numpy, mlflow, sklearn, your basic ml algorithms are required, plotting algorithms are required, mathematicals are required, data processing is required, of course math is obviously required for sure. Mlflow is the hero here. It does just all sort of and instances which should be ran. So very simple. Just like we set a Spark session, we are supposed to set an ML flow environmental experiment. Like it should be something like as soon as there is a trigger on an ML flow pipeline there, it should trigger on the experiments here. So what we just do is very simple. We just go ahead to the workflows. We just create something called as an experiment, or else we just go ahead, click in as a new experiment, and you can see that I have already added it, right? So you guys can see that there is an experiment which is already being created. So this is actually the way, but there is one more way in which you can go. So click on this machine learning thing, click on this. There's something called as experiments, right? You can create your new experiments, ML for release notices, everything will be created. So very simple. You can create a notebook, that's also there. Create, go to the workflow here, that's also feasible for you, but there is something called as experiment which is already being done for you. So click on it, create a new experiment, say it as any one of the experiment that is required. So go ahead, click on it. So data sets are already there, so I think that got clicked to an new experiment, but where is it? ML flow example is already being created, but like I don't think this has an experiment to be created. That's all right. Create a blank experiment. That's also you can do. That's the thing that you have to do. By the way, so let's say which was 1, 2, 3, 4, 5. So now if you create that, there is already an experiment which is created. Now you created a setup saying that hey, this is what we required for our entire infrastructure. We need to know all the things that is happening in and out of this entire uh, infrastructure that we have today. And if you click on any of the experiments that I've created before, you guys can see that how much of a run happened, when was the last one which happened, the ML flow execution dot an example. It's saying where did you get the source from and what and all happened, and everything about the version is being taken care, as well as you get some code. You guys can go check out all these codes and everything. So everything will be taken care here. And also there is and create an auto ML experiments as well, so you guys can go check it out as well. So it's a regression. So if I do select from data default, may I want to just do spam, I want to do classification, prediction target at C1. So it's actually C naught, by the way. It's a C naught as spam or ham. Prediction targets are already there, experiments. So if I start an AutoML experiment, it will always be there. C naught had the spam or no ham message, and everything is being taken care. So what you did with an ML flow there, I think this doesn't have anything. It just created a blank one for me. But like what you created in terms of multiple models and multiple things, multiple matrices that you took care of, all the matrices here, right? It's now being given here for you. So if you create that auto ML experiments, you will see that there is an overview which is happening. Of course, there is a start and stop thing which will obviously come here. So this is a very simple thing. What we just did was an end-to-end ML. So you can go ahead, get the dependencies and everything. So that's also there. So let's just go ahead with the same old ML flow. So I think I can just show you all of this. So we just started running it. So Databricks CLI, as this MLflow set experiments was not being running properly, I had to do this. Then later on, it started working. So sometimes what happens is like if you don't have an upgraded version of an Databricks CLI or anything, probably it might not communicate with your experiment. So that's what happened, and I did this, and this got sorted, and we did all the experiments and all the things. And now I am just loading in the different diabetes data sets, and I'm now making an just a quick intro of all the analysis that we really wanted to work towards. Wait. All right. So yes, we have to. It has to be run again. Sorry for that. I hope nothing really made a mess here. So let's see. All right, now this will start working. So head everything, all these commands will be in pandas. It will take me a lot of time if I start explaining a lot of things here. So just go through the document, everything will be same. I think you if you just follow all my notebooks which I have just ran there, it will be very useful for you as well. So you guys can start running. So as told, if you click on any of those models that were being stored in that experiment column there, you will get all the different run ids, load the models, everything, so you guys can just go check it out. So it's a simple copy paste thing. So reproduce run, I don't want that to happen, so don't worry about that. So it's a simple thing. Click on this, click on any of the model, and you are good to go. You will have all an end-to-end infrastructure which is always there for you. And of course, you can see that there was a recent run which happened. Refreshing it. Let's see. Oh, okay. I have not yet ended the experiment, right? So sorry for that. Error in command tree. What happened? ML flow is not defined. Why? All right. ML flow exam. Okay, this is now running it in ML flow instance. Okay, fine. You want that? I can do that as well. That's not a problem. So it's now being set. Perfecto. So I think ML Flow, that new experiment that we had, should have it updated some sort of a session right now. So let's see whether this ML Flow is now running. So it now has the notebook. Perfect. It now started running. So a minute before we started running this, and 53 seconds ago, it ran some sort of a matrix, and it's now there for me. So let's see what is going to be run right now. I think what's wrong with this revision history. So git sync, I'll come to that as well. Don't worry about that. So I need a new one. Experiment UI is okay, but like I need a new one. So alpha 101 and everything got sorted here. Let's refresh the page. Sometimes this also becomes a problem. Databricks also leads to a lot of production issues as well. So it's being considered good in terms of ETLs and everything, but sometimes it goes back. Your view, okay, sorry for that. Sorry for that. I think 1233 version is always there. So let's just run the new experiment only. So ML Flow I had installed, so that's perfect. ML Flow should be there, or else it's going to be very bad. None of the experiment will start running now. So you're using pip version available. Okay, I'll just do that as well. So let's see whether this will start working. Okay, so man, there is a lot of things here. All right, this is not working. That's not a problem, but like I can show you the experiment runs which happened and everything. So wait, let's see whether the other of the experiments will start working or it's not. All right, that's not a problem. So I think this has been set. Perfect. Perfect. This ran. This also ran. Perfect. This is now running. This is now running. So what I did was all the ML regression, tree database, test database, everything. And now let's see what happens to that one run that I had. So it's an ML flow run, which is now being happening. And now you can see that there is an execution happening. And mean square error was already being taken care. Alpha was already taken care. RMSE, R2 values, everything. So you can store the matrices. For that, the command is very simple. It's just log parameter. mlflow.log parameter is going to give you all the things that you wanted. So right now you just log the parameter, and now you will also log and model as well. So we'll go ahead in the future. So Cborn, everything has been taken care, and now we have all the runs which are happening right now. All right. This will start saving a lot of figures, lot of peanut. Why did it run as peanut thing? All right. So all of it just came in. So now you guys can see that. How can I go ahead and save a model? So it's basically auto save that I just did. So if you see the above code, I have written saying that wait. It's TensorFlow.auto save and everything. All the plots, everything got saved. And there you have it, an end-to-end metric which is being analyzed, an end-to-end state of all the things that you just had to do. It's being analyzed. So what I did was the Spark SQL, and now I'm taking in all the data and see the magic of it. I didn't do much of a work here, but I just have all the matrices in my experiments right now. So ML flow, you guys can see that, right? There is already a model which is already being built. Everything end to end is being now taken care. So it's now logging all the matrices. That's perfect. So yes, ML flow log parameters, ML flow. If you see that, it's already logging all the parameters. Of course, log artifacts. Of course, yes, it has to do a lot of artifact rebuild and everything. So that's what you saw here. Whatever you're taking in, this is all artifacts at the end of the day. The notebook is an artifact. Everything that you're doing is an artifact here. So I think I can show you that log metrics, everything sorted, artifacts taken care, artifacts has a model, everything is being taken care. If I change this, let's say, let me just say, put it in a form of an H5 file. Let's say this log artifacts in the form of an H5 file, and I run this. The magic of this run is it didn't work. Like it knows that this has to be in the form factor of a text, and if I run that, this will start working. And you can see all the runs which have been taken care here. It's all